Hello all. Today we will discuss fragmentation and reassembly. But before we move on to the calculation that two end devices do to perform these two functions, let us first go to the IP header and understand the four fields that come into play when a router or any networking device per se perform fragmentation and reassembly. Those fields are identification field, offset field, don't fragment field, and more fragment field. Those are these fields here: identification, don't fragment, more fragment, and offset field. But why do we need to fragment a packet? Let us consider a router that is R1, whose MTU is configured as 500 bytes. MTU is maximum transmission unit, and it is the maximum size of a traffic that a router can send out its interface. In a very simple language, this is what MTU means: the maximum size of the traffic that a router can send out its interface is MTU, or maximum transmission unit. Now, for example, it receives a traffic which has a size of 1500 bytes. How will R1 treat this traffic? Usually, any networking device accepts a traffic that has a higher MTU than what it has been configured for. So here R1 will accept this 1500 bytes of traffic, but when it is sending out, it will divide it into smaller fragments. It will divide it into 500 bytes of fragments. So it will fragment three times. Now, consider that there are multiple routers in between, and the end router is R50. How will router 50 know that these 500 bytes of fragments are a part of one single IP datagram? Or the most important part, how will it know, or how will it rearrange these fragments into the same sequential manner that R1 sent out? So the identification field gives an identity to these fragments, saying that these fragments are part of one single IP datagram, and the offset fields helps in rearranging these non-sequential fragments into a sequential order. Let us see how this calculation is done on the sending side and the receiving side. Please understand that the reassembly of fragments is usually done at the destination device. The in between devices, that is from source to destination, the devices that are in between will not perform reassembly. The reassembly is always performed at the destination device. Now, let us consider that we have a router whose MTU has been configured for 325 bytes. Now, when we usually configure an MTU on a router, it is also inclusive of the IP header. The minimum size of the IP header is 20 bytes. So the actual MTU that is configured here is 305 bytes. Now, let us take an example where a traffic whose MTU, or whose size, is 1500 bytes is received on a router whose MTU is 305 bytes. What will happen? Here, the router will divide it into multiple fragments. So how many fragments will it do? It will have 5 fragments. So we will have 305, 305, 305, 305, and the last fragment will have 280 bytes. Now, these fragments have been completed. Now, this particular router has to give it an identity. That is the work of the identification field. So, identification field gives it an identity. Here, let us take an example that the identity given by a router is A. So, all these fragments will have an identity of A, right? Then we have more fragment field. In the IP header, we have a don't fragment field and a more fragment field. When the router does not perform any fragmentation, meaning that the MTU that has been configured on the router is larger than the traffic that it is sending out, there is no need for fragmenting the traffic. So the don't fragment bit is set to 1. But here in this example, since the MTU is way less than the traffic size, fragmentation has been performed. So the more fragment bit in each of these fragments will be 1. So the first fragment here will say, do I have further fragments after me? Yes. The second fragment, do I have further fragments after me? Yes. Same goes for the third fragment. Same goes for the fourth fragment. The last fragment, it sees, do I have any other fragments after me? So, no. So that becomes 0. Now, the offset field. Before going on to the offset field, offset is not a binary field. That is, it will not have a 0 or a 1 value. It usually has a number. It usually has a value. To understand that number, we have to consider few things. What is the maximum size of an IP datagram? The maximum size of an IP datagram is 2 power 16 minus 1. That is 65535, 65,535. Now let us consider that there is a traffic that is received by this router whose size is 65,535. This particular router divided into divided this particular traffic or this particular traffic into multiple fragments. Fragmentation is easy, but the reassembly, how will, as I had mentioned earlier, the offset field helps in rearranging of multiple fragments. Now, offset field is actually of 2 power 13 bits. Now, how will the offset field rearrange or tell the end device of a traffic whose size is 65,535 or whose size is 2 power 16 minus 1? Because the offset field itself is 2 power 13, it cannot denote a traffic whose size is 2 power 16. So we are actually in a difference of 3 bits, that is 2 power 3 equals 8. Right now, with this purpose, what we usually do is that we divide the traffic, or we reduce the traffic, or we give a value to the offset field by dividing the bytes, or by dividing the size of the fragment by 8. So here 305 is not exactly divisible by 8. So usually the routers, what they usually do is that they take the fragments, or they keep the size of the fragments that is exactly divisible by 8. That is exactly divisible by 8. So during fragmentation, we divide the we divide the value of the fragment, the size of the fragment by 8, and in reassembly we multiply it by 8, right? So now do not think much about it. You will understand the value of this offset and the calculation of the offset when we are doing the reassembly. For now, just consider that we divide the size of the fragment by 8, exactly divisible by 8. Since 305 is not exactly divisible by 8, because 305 divided by 8 multiplied by 3 gives us 24. So we have 6 multiplied by 8, it gives us 64, and the remainder is 1. So 304 is the recommended size that the fragments will, it's not the recommended size, 304 bytes will be the size of each fragments here. Okay, so instead of 305 we will have a fragment of size 304. Here also 304, here 304, here 304. Now since we have taken each byte from all these fragments, the last fragment will have these fragments. So instead of 280 we will have 284 bytes in the last fragment. Okay, so now offset field says that how many bytes do I have in front of me. So for the first fragment here, for the first fragment here, how many bytes does it have in front of it? It does not have any bytes in front of it since it is the first fragment, right? Now the second fragment, how many bytes does it have in front of it? It has 304. So as I had mentioned, the offset field is usually denoted by a value that is divisible by 8. So 304 divided by 8, it gives us a value of 38. Now, this is the offset value of the second fragment. Now, the third fragment, it also does the same calculation. How many bytes do I have in front of me? That is 304 plus 304, which gives us a value of 608. And if we divide it by 8, it gives us a value of 76. Similarly, the same calculation goes for the fourth and the fifth fragment. So we have an offset value of 114 here and an offset value of 152. Now, again, I will explain that identification field gives an identity to all the fragments that are there. The more fragment field says that how many do I have any further fragments after me, and that is how we calculated this. The offset field says that how many bytes of data do I have in front of me. So for the first fragment it was 0, for the second fragment it was 304, and since we divided it by 8 we got an offset value of 38. Similarly, 76, 114, and 152 are the offset values of second, third, fourth, and fifth fragments respectively. Now, this these are the values that are present in each fragments. Now consider that these fragments are sent out of the router, but these fragments are received in a jumbled manner at the end device. How will the router or the end device rearrange them? Okay, it's very simple. What it does is it uses the it uses identification field, and what it does, it collects all the fragments that have an identification field of A. So we have 5 fragments that have an identification field of A. Now, what it does is that it says that whichever fragment has a more fragment value of 0, keep it in the last. So here we have, right? So since we have the more fragment bit set as 0, it goes into the last. Similarly, it will also have an identification, sorry, the offset value of 152 set here, offset value. Similarly, it says whichever fragment has the offset field of 0, keep it in the first. So here we got the first and the last fragments. Now, all that router has to do is calculate the fragments using the offset fields and rearranging them. So it got the first fragment. It knows the size of the first fragment is 304, right? Now it will have multiple offset values. It will have 38, it will have 76, it will have 114 here. All it does is, as I was saying earlier, when it is reassembling, it will it will multiply the offset value by with 8. It will multiply the offset value with 8. So what it does is, it's let's for example, it says that it receives the third fragment, that is this particular fragment. What it does is, it says 76 times 8. It got 608. Similarly, for 114 also, it does multiply by 8, right? And it gets a value of 918. And here, when it multiplies it by 8, it gets a value of 304, right? So we already have an more fragment bit of 1 here, right? Now, using the offset value, as I was saying, offset value denotes how many bytes do I have in front of me. As it already knows that the first fragment's size is 304, it tries to find out an offset value whose number is 304. Since the second fragment has 304 bytes ahead of it, it places the offset value here, 38. Similarly, it knows that the third fragment will of course have 304 plus 304 bytes ahead of it. So it places the 76 number offset on the third here. Similarly, for 100, for the fourth fragment, it knows that the fourth fragment will have 304 plus 304 plus 304 fragments ahead of it. So it keeps the 114 offset here. And this is how the end device rearranges or reassembles the non-sequential received fragmented packets into a sequential order. So please, if you guys are unable to understand the fragmentation and reassembly, please go through the video a couple of times and do let me know any of your doubts in the comment section so that I can clarify them. Thank you and have a nice day.